need to do is count the atoms on both sides of the equation. Can anybody tell me, raise your hand, how many atoms of each you have on the left side of the equation?
2.
Tristan?
2.
2 and 2. Okay. Somebody different for the right side of the equation. Michael?
3.
3 hydrogens, and how many nitrogens?
1.
1. Okay. Now, the point of law of conservation of mass is that we have 2 nitrogens before the reaction and only 1 after, 2 hydrogens before the reaction and 3 after. We can't have any matter created or destroyed, so that's why we need to balance the equation and find the correct ratio. So, this is not balanced right now. Raise your hand if you know what I could multiply NH3 by to get the correct number of nitrogens on each side. We want 2 nitrogens on each side. Do you want to try? Take a guess?
No.
2. Okay. If we multiply NH3 by 2, that will give us our 2 nitrogens, right? But then what's the problem with the hydrogens?
You have to find a common denominator.
Close. Well, we will be in a minute. How many hydrogens do I now have on the right?
6.
6. It's almost like this is in parentheses. Okay, now we have 2 nitrogens, 6 hydrogens. Okay, so nitrogen is balanced. Now hydrogen is not balanced. And what could I do to fix that?
3.
Put a 3 where?
Either way, right? Could you multiply it by 3?
Multiply what by 3?
In front of the H.
In front.
In front of the H, we need to put a 3 because we have 2 hydrogens here and 6 here. If we put a 3 here, then we'll have 6 and 6. And then your final answer is just basically going to look like this. Okay. Now, number 2.
Oh.
Okay, now we've got 3 elements this time. And Carl, count the left side. What do we have? How many of each?
We have 1 K,
Yes.
1 Cl,
Yes.
and 3
Oxygens. Yep. Okay, Jack, how about the right side?
This is bad camera work.
1, 1. 1, 1, and 2.
Okay, now these are balanced right now. We need to do something to fix this, and someone had mentioned least common denominator. Raise your hand if you think you know what to do. Okay, go ahead.
You have to put a 2 in front of the one that's 3, and then a 3 in front of the one that's 2 to make them both equal to 6.
Okay, good. We need 6 and 6. So if we put a 3 in front of O2, that'll give us 6 oxygens, right?
Yeah.
If we put a 2 in front of KClO3, that will give us 6 oxygens, but what does that mess up now?
The
KCl.
These are now off balance because these are now how many?
2.
2. Okay. Raise your hand if you know what to do next. Okay, Diana?
So then you put a 2 in front of the KCl.
Okay, good. We have 2 and 1 and 2 and 1, so if we were to put a 2 here, then we'd get our everything equal on both sides, which is what we're trying to do. It doesn't matter how many of each you have, you want it to be balanced. Same number of atoms before and after the reaction. Okay. So we'll do 1 or 2 more. Okay, so we have sodium, chlorine, fluorine. And Kaylee, can you cut the left side?
1,
Mm-hmm.
1, 2.
Yep. Okay. Jillian, how about the right side?
1, 2,
Mm-hmm.
1.
Okay, James, what 2 elements are off balance?
Cl enough.
Okay, so these are not balanced. We need to fix these. Okay. Raise your hand if you know what to do. Go ahead.
Good. 2 root of Cl on the right side and 2 root of the F2 on the left side.
Okay, well we need more chlorine on the left, and we need more fluorine on the right, and what did you say each one of them needed?
2.
A 2. If we put a 2 here, that will fix the chlorines, but it also changes the sodium, right? Now we need to fix the fluorines, so we put a 2 here, and that should fix everything, and then your final answer. Now when there's no number here, that means a 1, but you don't have to write it. Alright, so that's the final answer. And okay, you guys should try it number 4 quickly, and then we'll put it up. You haven't heard any purposes?
No.
Why?
Want me to?
Well,
Oh, wait, yeah, don't you multiply the O by 2 on the right side?
okay, if we multiply this by 2,
Game changer.
now what? What has happened
Wait,
here?
that gets multiplied by 2 too?
So what is this now?
Oh, that's 4, right?
Mm-hmm.
So then multiply on the left side by 2 hydrogen?
Yes. Okay, done.
That's easy.
Okay, the more of these you do, the easier it gets. So we'll do one more. This one looks a little bit longer, but it's not bad. Okay. Who remembers the name of NO3? Carl?
Phosphate.
Nitrate. Nitrate, okay? So what you can do now, you are welcome to break this down into elements, nitrogen and oxygen, but even better, if you count it as ions.
Whoa.
So CC, count the left side. Mm-hmm. Yes.
1.
It's 3 oxygens, but it's 1 nitrate.
1.
Mm-hmm.
2.
Yeah. Yep.
Yeah.
Yep.
CC's voice got suddenly very deep there. Okay. Who can count the right side now? Maybe Nick.
1.
No, not yet. James?
1.
1.
Okay, we've got 1 silver.
You got 2 of those.
Okay. Blake, how about these two here?
1.
Yeah?
1.
Okay. So what 2 elements are not balanced? Melissa?
Nitrate.
Okay. Nitrate is not balanced.
Chlorine.
Chlorine. Okay, so we're going to need more chlorine on the right, more nitrate on the left. Raise your hand if you know what to do. Go ahead, you want to try? Go ahead.
You added 2 to the magnesium nitrate. Right there. Yes.
Right here?
Yeah.
But if we put a 2 here, then how many nitrates are you going to have?
4. 6. 8.
Okay, so Michael, where would we put the 2 instead?
You can put an AgCl, right?
Okay, that's one thing we need to do to fix this.
Then you get another extra
Oh,
Ag
it's
and agree on the left.
Just say it.
Okay?
Oh.
It's going.
Last question.
Okay,
I'm sorry,
Good.
Alex. You cut it out.
go ahead, you can stop.